Hello dear students, this is the continuation of exception handling. We will focus more on try-catch block in this particular tutorial. So let's begin with a tiny code. Just try to recall that we talked about a function which is f of n is equal to x divided by x minus 5. So we will try to reconstruct that function with the help of a min to understand the try-catch block further. So here we construct a method which is f, and it takes an integer and do the calculation x divided by x minus 5 and gives you the output. Now as this method is a non-static method, so to access that method we need to create an object, and therefore we include public static void main under the main class itself. And at line number 6 we create an object of main class, and with the help of that object we call the method by passing an integer value. Now from where we will get that integer? Well, to pass the integer value we take help from the command line argument. So when we pass a value from the command line, it will eventually pass that value. Now as it is a string type of variable, we need to convert that string into the integer before putting it into x. To convert it, we take the help from a method which is there in the integer class, and the name of the method is %. So let's look how the code will react. So for the simplicity we will only take this 3 instructions within the main method. So if we try to execute the class as Java main, that means we are not passing any value to the command line, then what happened? Well, at the time of execution it fails. Why? Because it requires some value, or Java try to access some value which is supposed to there in args 0, but Java won't find args 0. So immediately it will create an object of array index out of bound exceptions and it will throw that object. Now what if we pass a value which is 5? Well, if we pass 5, then here % change it to integer 5, and now we will send 5 here. So f is now get 5, and here we try to get the value of 5 divided by 0. So at that point, or at line number 3, Java finds there is an exception which is arithmetic exception. So Java will immediately create an object of arithmetic exception, and then this object will pass to ob.f within bracket x, and from that line we will finally have an arithmetic exception and system stops working. So this is what we will get if we try to get the output through command prompt. So when we call Java main, it will gives you the array index out of bound exception, and that exception happens in line number 3 here. But when we pass 5, there is an exception which is arithmetic exception, but this exception actually occurs at line number 3, and due to that the line number 8 also gets affected, and finally from the line number 8 the system stops its normal flow of execution. So how to resolve from that issue? Well, we already know about try catch block, so we will take the help from try and catch. And in both cases we handle the exception. So whenever there is an exception, whether there is an arithmetic exception or array index out of bound exception, we will just say an exception occurred. But what if we try to handle these two different exceptions explicitly? Means suppose for whenever we get array index out of bound exception, we try to inform the user that command line argument is needed, whereas for arithmetic exception we will inform that press any integer other than 5. So we basically try to handle the different exception explicitly or differently. So can this work? Well, how this try-catch block actually working? So let's see that. So when we try to call that particular code as Java main, we have an array index out of bound exception, and now this catch block, which takes an object of exception class, it's basically a generalized catch block. So that means all type of exception, no matter whether it's a checked exception or runtime exception, that can be handled by this catch block. So this catch block is eventually able to handle an array index out of bound exception as well as an arithmetic exception. But how to handle it explicitly? Now it's more like taking a stairs. Now suppose there are two rooms in the stairs where you will find that under one door the arithmetic exception can be handled, and it will say press any integer other than 5, and in another door an array index out of bound exceptions can be handled and it will say command line argument needed. So whenever there is an array index out of bound exception, we took the stairs and first find the door with arithmetic exception, but we are not interested about the door. So we will go forward, and finally we found array index out of bound exception door, and we entered the door and handled the exception like command line argument needed. On the other hand, when there is an arithmetic exception occur, we will go and find the arithmetic exception at the very beginning, and we are very much interested about that door, and we entered the door and we finally handle that exception as press any integer other than 5. So Java did exactly the same. So let us see the code. So in this particular code, instead of one generalized exception catch block, we now take two different catch blocks, and this is more like a ladder. So we call it try catch ladder. Now whenever there is an array index out of bound exception occurs, so our system or Java will first visit that catch block and find this catch block takes an object of arithmetic exception, but our object is not arithmetic exception but array index out of bound exception. So from this line it will jump to the next catch block and then find it is an array index out of bound exception. So this catch block is able to tackle this exception, so it will handle that exception. On the other hand, if there is an arithmetic exception, it will immediately finds in the very first catch block. So how the output looks like? So when we have Java main, we will get command line argument. So we very much effectively handle that exception. When we try to execute the code as Java main 5, we will get press any integer other than 5. So now we can see that we handle two different exceptions differently with the help of the try catch ladder. Now, is there any further problem? Well, there is. What if we, instead of 5, what if we send F5VE as a string? Now this sparseInt method is able to convert a string integer to an integer type value. That means if we send 5 as a string, it can able to convert that string into integer as a or string to integer. That means to convert the 5 as a string and the number 5 should be matched in terms of format. But here we send 5, so it will generate another exception, which is number format exception. Now we do not have any catch block to handle that type of exception. So what actually happens here is, when we have Java main 5 or when we try to run the code as Java main 5, there is an exception occurred in line number 8 because the % fails and it finds an exception which is the normal format exception. So Java immediately create an object of number format exception and throw that object. So that object is now checked the first catch block and finds this catch block is able to handle only arithmetic exception. So it goes to next catch block and it finds this catch block is able to handle only array index out of bound exception. So it moves further and finds there is no other catch blocks. So finally our system fails at that point. So from line number 8 there is a number format exception and there is no such catch block which can able to handle number format exception. So system stops working properly. So how to resolve from the issue? Well, we will include a generalized exception block. Now why the generalized exception block, not another catch block with number format exception? Well, that depends on the requirement. Now here our requirement is to focus on arithmetic exception and array index out of bounds exception. So we only try to handle the exception explicitly for arithmetic exception and array index out of bound exception. For all other exception we are not try to handle it explicitly, but we just simply handle it in an overall manner. Then that's why we take the overall exception catch block or the generalized exception catch block. Now if your requirement is to handle number format exception explicitly as well, then we will put, then you have to put the another specific catch blocks with number format exception. So now let us see what happened when we try to execute the code as Java main. So this exception is handled by array index out of bounds exception catch block and the arithmetic exception is handled by arithmetic exception catch block, and for number format exception neither of these two catch blocks is able to handle it, but the generic catch block which is the exception that will able to handle it. So how the code should looks like? Now the code should looks like this. So here we have 3 catch blocks in our ladder. So first it is the arithmetic exception catch block and then the array index out of bounds exception catch blocks, and last one is exception catch block. Now here one important thing we need to notice, and that is the arithmetic exception or array index out of bound exception or all other exception are basically the subclasses of the generalized exception class. Now what happen if we put that catch block with exception in the very beginning? Well, as it is the generalized exception block, this catch block is now able to handle all type of exception. So if we put that catch block at the very beginning, and let us take this is arithmetic exception block. So if we put that catch blocks at the very beginning, so no matter whatever the exceptions will occur in the try block, all the exceptions will handle by this particular catch block. So whether any exception will reach to these catch blocks? Well, the answer is no. So basically these will become an unreachable catch blocks. Suppose you have a person which is way bigger than you and you are behind the person. So can anyone see you? No. So that's the reason we must put the exception catch block at the very end, not in the beginning. So after exception catch blocks, we can't expect any other catch blocks. And if we do that, it will lead to an compilation error.